Right, so what we're going to do now is have a look at stoichiometry. That's a very fancy word for the relative numbers of moles of things that are happening in an equation, and then reacting quantities. So this is something you may have done at GCSE. When we look at a chemical equation, like this one here, we can see that this equation tells us something. It tells us that for every 2 moles of sodium, we're going to need 2 moles of water in order to form 2 moles of sodium hydroxide and 1 mole of hydrogen. That is a ratio, so that is 2 of these to 2 of these is going to produce 2 of these for every 1 of those. It's a set of ratios. So we can scale that ratio up or down to work with any quantity. So if we started with 4 moles of Na, how many moles of water would you need? How many moles of sodium hydroxide would you form? And how many moles of hydrogen would you form? So have a go if you're scaling it up to 4. There we go. If we scale it up to 4 moles of sodium need 4 moles of water to give 4 moles of sodium hydroxide and 2 moles of hydrogen. What if we scale it down? What if we scale it down and start with, could you do it starting with 1/2 mole of sodium? So how would these numbers change if we had 1/2 mole of sodium? Have a go. So there we go. If we had 1/2 mole, we'd need 1/2 mole of water to give 1/2 mole of sodium hydroxide and 1/4, 0.25 moles of hydrogen. So we can scale up or down to any quantity, and this is really important for our calculations in chemistry. So let's put that to some use. The question is, what mass of magnesium oxide? So if I was reading this in an exam, one of the first things I would come across is, what's the formula of magnesium oxide? Magnesium is in group 2, so it's a 2+ ion. Oxide ion is O2- because oxygen's in group 6, so MgO is produced when 25 grams of magnesium carbonate, MgCO3, is heated. So what information have I been given? I'm asked what mass of magnesium oxide, but I'm being told 25 grams of magnesium carbonate. Now, one of the things that I would probably do first, although it's a bit later down this page here, is write the balanced equation, which shows how magnesium carbonate reacts to give magnesium oxide. And I would think about what the ratio is. The ratio there is 1 to 1, and also the carbon dioxide is 1, but we're not interested in that. So how would we do this question? Well, because we're working in masses, to convert to moles, we remember that mass is Mr. Moles, so we're going to need some MRs. So let's add up the MRs. So get out your periodic table, pause the video, add up the MRs of magnesium carbonate and magnesium oxide. And we should have got 84.3 and 40.3. So to work out the moles of magnesium carbonate, remember we're going to need the mass of magnesium carbonate, which was 25, and the MR of magnesium carbonate, which was 84.3. So again, on your calculator, work that out. Should have got 0.297. Now, the molar ratio shows us we can scale up or down to any quantity. So if 1 MgCO3 makes 1 MgO, then 0.297 will make 0.297. The ratio is 1 to 1 between the magnesium carbonate that I've got and the magnesium oxide that I want. It's 1 to 1. Sure, that one should have been in yellow, shouldn't it? And so it's 0.297 moles. And then I can finish off by doing mass is Mr. Moles. I already worked out the MR as 40.3, so I can finish off my calculation to work out how many grams that would relate to. And that's coming out as 12 grams to 3 significant figures. So let's look at our second example. See if you can work out the MRs of these two, sodium carbonate and sodium chloride. So I've worked out the MRs, and now I can use my formula, my equation to get the number of moles. So 10 over 106, and we're getting 0.0943. Now, according to the balanced equation, 1 sodium carbonate makes 2 sodium chlorides. So to get from 1 to 2, I have to multiply by 2. We're starting with 0.0943. So I'm going to multiply by 2 to find out how many moles that would be, 0.189. So from the balanced equation, the ratio between sodium carbonate and sodium chloride is 1 to 2. So I have to take my number of moles of sodium carbonate and double it. That's what we just did above under the equation. So 2 times 0.0943, 0.189. That's keeping it on your calculator, by the way. If you have retyped, you might get a slightly different number. And then mass is Mr. Moles, and we worked out that the MR was 58.5. And we get 11 grams to 3 significant figures. So why don't you try this question? You will need to try and come up with the balanced equation, although we have already done something very similar in our first example. So there is an equation there that will give you an idea. So there we go. I've written the balanced equation. I've worked out the number of moles. I've remembered to convert kilograms into grams. I've calculated my MRs in order to do that. I've looked up at my ratio, which is 1 to 1. So the moles of calcium carbonate is the same as the moles of calcium oxide. And I finished off by calculating the mass and converting it back into kilograms. So we should have got 1.78 kilograms.